Hello, this is Dr. Kraus with the second video in this new series I'm doing on Intro to PLCs. In this video, I want to talk about fundamentals of ladder logic. Just a quick review in case you missed the other video or want to go check that out. In that video, I talked about what is ladder logic, how it has rails and rungs like a ladder. We talked about who is capable of learning ladder logic, pretty much anybody. We talked about how it is kind of a rigid structure, which can be both a strength and a source of frustration. And we talked about how each rung is executed sequentially, and then the code just keeps looping through those rungs indefinitely. In this video, I want to introduce you to how to create rungs, how to create branches, and then the most common elements you're going to see in ladder logic. So the first thing you'll need to do if you want to add some new chunk of code, that code comes in rungs. And so there'll be a button on your screen that kind of looks like an H. This is supposed to be the power rail, the ground rail, and then an empty rung. And so if you push that button, it should add, and I'll do a quick demo of this in a little bit, add a rung to your logic. If you needed to add a new branch, we talked in the previous video about how maybe you would have an OR in your logic, and so if this rung were true or this other branch, so these would be two different branches, and so this could be an A or B, causes the output to be true, that kind of thing. So a new branch button is also going to show up in what is called your favorites in Rockwell Studio Logic 5. Rockwell Studio 5000 is the software that we're going to be using. So this is a screenshot of that. These are your favorites. Here are your 1, 2, not sure what that one does, 3, 4, 5, 6, 7 favorite buttons. So, new rung, new branch, and then we'll talk about each of these 5 in the next section. Do that now. So, examine on or an XIO, examine off or an XIC. Output energize is OTE, output latch, OTL, and output unlatch is OTU. Let's go through each of those. So an XIO, brief bit of context, PLCs and ladder logic were kind of the next step in kind of the technological evolution of relays. And so it's just kind of, a lot of the terminology is borrowed from relay terminology. So it'll be a little weird to talk about a normally open relay, but that's what another name for this XIO. So examine if on, or XIO, meaning it's like a relay and it's normally open, normally off. Normally there's, this is just an open switch. And so what that would mean is if the switch is open, if this is connected to your power rail, 24 volts or whatever, and this is open, then this would be floating or basically 0 volts here. So it is essentially reading one digital input, and if it's off, then the output is off. If the switch is closed, so if there's 24 volts here, then it would connect this output side to 24 volts. So if the relay is closed, or there's 24 volts here, then the XIO is considered on. So its default is an open switch. You could think of it when closed as connecting to that 24 volt power rail. So an XIC is the opposite of an XIO. We're examining if it is off. So you'll see this kind of knot symbol here in between the two. And what we're trying to mimic is a normally closed relay, meaning in the normal position, which is also called considered the off position, then there would be a connection between the input and the output of the element. And then when you open it, then it would be considered on. So if there is a connection between here, it's off. If that connection is broken, then the output comes on. So again, think of that as the opposite of an XIO. We're examining if it's closed, and if it's closed, we consider that off. So when it's open, the output would go back to floating. When it's closed, there would be a connection between the 24 volts and this side of the element. So those are our two main input elements, and we've got 3 different output elements that we're going to talk about. The most common one is OTE, or output energize, and so it kind of looks like parentheses, And the main thing is there's nothing here in the middle. And so basically, if this input side is on, then turn it on. If the input side is off, then turn it off. And so that is an OTE. So it responds to either on or off by turning the element on or off. Whereas output latch, OTL, is only going to turn it on and will never turn it off. So if the input is on, turn it on. If the input is off, do nothing and just leave the output in whatever state you found it. So only turns it on, only latches it up, OTL. So the opposite of an OTL is an OTU, or an output unlatch, with the U in the center here. And essentially it only turns the output off. So if the input is off, turn the output off. If the input is on, leave it alone, do nothing, leave it in whatever state you found it. So those are the 5 most common elements of ladder logic, along with how to create branches and rungs. And I'm going to do a quick example from my other computer now. Okay, so this is a quick demo on the things that we just talked about regarding the your favorites and the most common elements. I'm going to grab a new rung. I'm sorry. First, I don't want to do that. So this is what happens if you try to edit code that when your PLC is actually running. I'm going to switch first to, I'm going to go offline. And that's going to make my editing easier. We will cover that in a future video. So I'm going to drag a new rung. I'm going to drag a new branch, and you'll notice you gotta move your mouse around until you get to the spot, and the little spot will turn green. I'm going to drop in an XIO and an XIC and an OTE. This is covered in a video that I'll publish later, but I'm trying to use these 2 switches. This one will be the XIO, this will be the XIC. And so those happen to be on local input module 1, input data 1. Again, you don't have to understand that right now. I will have the the Hello World video that I'll publish shortly on how all of that works and how to add modules to your project and whatnot. So I need local to output data 1. So because of what I know about my system, I know that these 2 switches, or these 6 switches, so this is local 1 input data 0, local 1 input data 1, local 1 input data 2, local 2 output data 0, local 2 output data 1. So I will now go online and download that code and show how this works. I think I got time for a quick drink of hot cocoa while I'm waiting. And then I'm going to switch back to remote run mode, so I'm actually running the code. And what I want you to see here is if I switch on switch 0, light 0 turns on because that's reading input data 0 and writing to local 2 output data 0. And then if either of these branches were to come on, the light would come on. So because this is an XIO, when I switch it on, the light comes on. When I switch it off, the branch goes off, and because the other branch is off, the light goes off. Whereas the XIC inverts that logic. So when I switch it off, the element comes on and the output light comes on. So off and on are backwards. So if either this is on or this is off, the light's going to come on. And if neither of those 2 things is true, then the light will be off. So hopefully that makes sense. I didn't demonstrate latch and unlatch. We'll leave that for a later video. Please let me know in the comments if you have things you'd like to hear explained better, or things that are still unclear, or ideas for future topics. Thanks.